Good afternoon, good morning. I don't know what time it is in Knoxville. It's 1:01 p.m. How's everyone doing? We're working away right here, getting some stuff done. Let's see what we got. There we go. We got stuff going on. We're gonna be looking to some project stuff with our studio. Let me see right here. I've got so much open right now. There we go. Let me go to the terminal. Let me clear my global environment. We're gonna look at some R projects here to start. But if you have questions, let me know in the chat. Let me go away from top chat. Let me make sure Mubot is awake. Let me re-wake him up. Mubot, you got to wake up, buddy. Here we go. Mubot is waking up. Let me go to a new project here in our studio. Let's save that working space. New project. Checking out the new project in a new directory. And let's go to new project. Mubot is loading changes logs. Sure. We will update you later, Mubot. I'm a little afraid to update you right now. Would that be crazy if we lost the Mubot stuff? But if you're in the chat, feel free to say hi. Test project. Create project as subdirect. Let's go test projects. Create this project right here. Oh, there we go. Nice. Working with this new project right here. Test project. Perfect. Love it. And so, yeah, we're going to look at this test project right here. I think it's in downloads. So I'll go over here to downloads. Let me try test project. Where's test project at? Test project in home, under home. But if you have questions, let me know right now. I'm just going through. Oh, where's it at? Am I inside of Git? No. Am I over there? Let's see. Review night. Where am I located? Files. Am I on Git? I don't know. If you're in the chat right now, feel free to say hello. I'm just kind of doing some exploring, looking around. Oh my gosh. 17 gigs free. Test project. Trying to find it. Where is that file located? Test project, where are you? You are online right now. Are we online? It does say we're streaming. Just kind of looking through right now. Where did I put this? Open project. Let me go to my GitHub. GitHub desktop. Good stuff. Go to here, put it over here. Just relaxing right now, getting some work done. If you join the chat, feel free to say hi. Oh, I need to put the Brian is taking questions thing. There we go. Now people can see we're taking questions. Let's see. See this? Local path. Awesome. This should. Hey, Abigail, good to see you. Is there any way we could start assignment 2? Sure. Assignment 2, is this 320? I think this is 320, right? Or is this 475? Which one is it, Abigail? Let me know. We're just listening to a little music right here in the background. Is that the same one? Hello, good to see you here. What would it say if I don't have the package called tips? So tips is a data frame. Let's go check that out. So 320, I think both people are doing 320. Perfect time right here. Let's go talk about some 320. And let me go over here to plots and let's do this. Let's talk some 320. Getting started on assignment 2 for 320. 525. BAS 320. Getting started on assignment 2. Let's go check this out. Here we go. So Abigail, let me know which things you want to work on the assignment. We can check those out. So with the tips data frame. So what we'll use a lot in this class, Ella, is a library called reg class. Now, what are libraries? So let's first talk about what is a library. Libraries are basically like you walk into a library and you have a bunch of access to stuff. Does that make sense? Like you walk into a library and you're like, oh, there's so many books, there's so many things for me to like use. So we're going to bring up library reg class. Now you might not have this at the moment. I'll explain why. When you pull up a library right here, notice how it's loading all these things. That's not error messages. That's just bringing your attention to a bunch of things that are happening by making the messages red. Over here, you'll see packages loaded in reg class. It's like it gave you a bunch of stuff. You have the data on your global environment. Perfect. So reg class actually has inside of it the tips data frame. Now, what you can do now is do data tips. And you see right here, this is the package it's inside of. So you need to make sure to load in the to load in data that is in libraries. Like this library has data inside of it. You walk into the library, like, oh, there's some data over there. This will load the data set up here in the brain of R. So now tips has been loaded in, and tips was in the reg class library, which the libraries are also packages. So you can actually see what's inside of it if you go to right here. I don't know if we can see the data frames. We can't. But you could also, and last thing I'll mention, and don't worry about doing this, delete this if you have it, you can look at all the different data frames inside of reg class right here to see which things are where. So you see right here inside of reg class, and you see tips is a data frame. There's a bunch of other data frames. These are basically Excel spreadsheets inside of the library you're using. And there's other libraries with other data frames like RPart. You might not have RPart, but I could load up the solder library, whatever that is, stage C library. So if I type in right here stage C, it'll bring up from RPart the stage C, and I could load that data in. Promise means it's there. It's promising to me it's there. I have no idea why it says that. It's just saying I promise it's there. And we can do some number one in a moment. You got Abigail. And so what you want to do, if you don't have where it says tips, but I think you do, Ella, you want to go to install packages reg class. Reg class has to be in quotes, and you will install it. And then after you do that, comment it out. But now you can load library reg class, which I think you've done. And then the tips data frame is inside of reg class. Tips is not a library, so there is no library tips. It's that the data frame is called tips, and it's in the reg class library. Ella, does that make sense right there? So tips, if you see it right there, is in the reg class library. It's just a data frame. It's like an Excel spreadsheet. You walk into the library, like, ooh, there's a data set I want to use. Does that make more sense, Ella? If you see tips up there, you have it. You just have to make sure when you knit that you do call it also in your file. Like if you're going to knit, your code will run in order. So you have to call data tips. If you do this right here, I wouldn't do that, but this would run where this right here would not run. If you had an RMD file, and we'll show this right here. This is a very good thing to know, and then we're going to do Abigail's question. Why will this file here not knit? So why will this file not knit? Watch, I'm going to try to knit it right here. I'm going to, because sometimes asked to save to my computer when I go to knit. Yeah, it does. Okay, let's say test file. Oh, sure, why not? So when I try to knit this, it runs into an error. Can anyone explain I'm going to throw 50 points automatically. Can anyone explain for 100 points why this file won't knit? And then we're going to do number one. Why won't this file knit right here? And so if the answer is I don't know, but it's a very good thing to know about how knitting occurs. And how knitting occurs when you create a knitted file from something is the file knits in order. So all the code is ran in order right here. So why is this file not knitting? And it says tips not found, but I've loaded tips. So why won't this file knit? Which a lot of people run into this. You say, well, everything's there. It's loading tips. Why won't this knit? So there's a really good question worth 100 points. If the answer is I don't know, that's fine too. But there's a really good problem a lot of people run into, and they're like, well, everything's there. I loaded tips. I pulled the library up. Then I've loaded the data frame. I kind of gave away the problem. Why won't this knit? And then we're going to do question one. Why won't this knit? Really good question right here. So we try to knit it. Guys say, I don't know. It just won't knit. It says it can't find tips, but I have the tips data frame right here. I didn't know if you click it, it went to it. That's interesting. It doesn't even bring you to the right line. It says line 19. Line 19 has no error. Whenever you get an error, it always tells you the start of the chunk where the error is at. So the error is actually sort of in here. So kind of, what it is since we're using tips right here, and since it does it in order, you have to load the data frame first. Does that make sense? So you would load the data, then use the data. You wouldn't use the data, then load the data. Does that make sense? Like this is using the data that we load down here. So what we need to do is we need to load the data, then use the data. So if you're going to use data, you must first load it. So you have to do things sequentially. While right now this will run like no matter what order I have it in, because tips has been loaded in, when you knit it, it does it line by line loading. So if you put it out of order when it knits, it'll say like, I don't have the data. Oh, that means not a number, not a number. So NA, and you notice how it changes colors? That means not a number. So generally, I think you get things like that if you do, is that infinity? That's infinity, 0 divided by 0, not a number. It means it just doesn't have any numeric value assigned to it. Good question right there, Ella. So it means you've ran into a thing where it says that is not a number. So it runs into issues where things are not a number. So certain mathematical expressions can't be expressed as a number. 0 divided by 0 is not a number, apparently. That's what NaN stands for. And notice how it changes colors. That means it's a special character inside of R. So we could say the first thing in this vector is not a number. The second thing is missing. And the third thing is 1. So this can still be right here a numeric vector. Or this might be an integer vector. It's numeric. So this is still a numeric vector. It's just the first thing in that vector is not a number. The second thing is missing. And then the third thing is the numeric value 1. So we could still do mathematical operations on this vector, and that's what's important. It just says that the first thing in that vector is not a number, but we can still do vector mathematics on it, and it'll just kind of avoid doing the mathematics on the first thing, just saying, well, that's not a number. We're just not going to do anything right there. It's a little bit interesting, like, why would you use not a number versus missingness? I don't have a good answer for that. That's Ella, if you want to go in more in depth, and yeah, like, so that stands for not a number. No, really good questions right there. Keep evaluating, keep looking, and ask those questions you run into it. What does the NaN stand for? I love it right there. Great questions. 100 points right there. We're going to jump into Abigail's question right here on. Let's start with number 1. So keep those questions coming. Anytime you see something, you're like, what does this mean? What is going on with this? What does it all mean? The big questions in life. What does it all mean? We're not here to answer that today. I'm not. Don't come to me with your existential questions. I don't. That's above my pay grade. I don't handle those questions. Do some for loops. We're gonna do for loops today. Oh my gosh, for loops are awesome. For loops make life so easy. Ella, I asked my fiance last night, what is the 3-letter word that's the secret word? And I said my students guessed bun, but I know I said my students guessed dog. And I said, can you guess it? And she just looked at me, she said bun. And I put in bun. My fiance guessed the 3-letter word I came up with like that. There you go. That's why she's my fiance. She knows. I say secret password's 3-letter word. It's just bun. We'll head over to the main screen. Take the timestamp right here. So, I know. I thought I maybe kind of hinted by saying like I was smiling when I said dog. Like, so when I say dog and I'm like smiling, I'm like being like wrong animal. Yeah, I thought it was awesome too. I think I said I'll give you 3 tries. And she's looked, she said bun. So I'm at 2, question 1. Okay, let's take a look at question 1. Here we go. Okay, lots of help right here. Really a step-by-step. But let's take a look right here at the first thing right here. A classic question to begin with on the 474 coding night. And we do have a coding night for 474. Don't worry. A lot of people freak out about it. But I'll say this. Some things we ask you to do on coding night is like the very start of it is store 10 into X and do 2 times X. Like we might write a question on coding night, like start of coding night. And people are freaking out about coding night, like, oh my gosh. Is something like this, usually. Part 1, store X into, or store 10 into X. And then part 2, multiply this by 2 or 10 or something, whatever. Like, we usually start with like very simple questions and build because the goal is to see like, well, how far can you get? Like, the goal is usually you're not supposed to complete it. I miss doing these in person lot of people absolutely hate this, and usually there's this like group of students outside coding night being like, oh my gosh, that was insane, what did we just sit through? Because the goal is we give you a lot of questions, we start them off very easy, and then we build and we build and we build and we build. Right now, Ella, could you do the start of coding night where it says store 10 into x and multiply this by 2? Like steps right there, like store 10 into x, multiply this by 2. So we're gonna start with the most basic of stuff, so which are things we should do a bunch. Like you'll usually, if we say store 10 to x, you should be like, got that. But it's scary to me, and I don't mean this in a bad way. This is why I miss doing it in person, because it's the best way to monitor that everyone's doing their own work. It's a lot harder online, but we've ran into issues where people in kind of the senior level classes midway through the semester have issues. Exactly, Ella, 100 points. So, you know, when you're in 474, we expect you to know things like that, like store this into this, like save the object, like maybe it's a communication thing. Like people can be like, hey, what do you mean store into? We're like, just assign the value of 10 into x. And they're like, oh, assign it as a value. I understand that. Okay, create this object. So always feel free to ask questions. We can always kind of rephrase stuff. So don't freak out about coding night. It's just to see how far you are and what you can do. And we always curve it. Or we have in the past. I can't say always, but we usually curve it. We want a distribution usually around 75, 80. So we kind of see where a good point is and where people's skills are at. And we kind of evaluate you. So you're kind of evaluated where you're at. So write a for loop that prints a paste of your name 5 times with a number as the second number to show how many times it has pasted to the screen. The coding night is open notes. Very important right there. And this question is often announced before the exam. This means you can write the code out. Okay, so whenever we create a for loop, and this walks you through the steps, whenever we create a for loop, what's the first 3 letters we write? And then we'll start to look at what is in the for loop. There's 3 things, but what's the first things we write when we create a for loop? What is the first thing we write to create a for loop? We're going to write a for loop. We're going to write what to start with. Yeah, of course. Ella, pick the next one. We'll do this one right here. And it's all right. Like, I can answer all the questions too. And Ella, thank you so much for being here. Put the question you want. We'll do it 100% next. You're here. You get to pick the questions. So when we write a for loop, we write FOR, and this pulls up the snippet. Now, you could write all that stuff right there. You could write it. So Abigail, great answers right there, Abigail. Yes, I like that right there. Because Abigail is already going to the parts we need for this. So we need a skeleton. We need a variable. We need a vector. The values the for loop will go through. A placeholder can be anything. Changes in the skeleton. Code that repeats. Try writing static first. How could we possibly, let's just say print our name. How could we print our name? Just tell me how to print my name. Like, tell me and we'll do Ella's question right there next. How could we just print our name, Abigail? Just think of a way to print your name. Like, give me a code in the chat that just prints Abigail. This is all I want. All I want right here is a code that prints Abigail. We're going to try to do the skeleton, which is our code. We're just going to try to write some code here that just prints our name. Because this says what I need to do is I need to say like Brian 1, Brian 2, Brian 3, Brian 4, Brian 5. So you can kind of see, let's just start by printing our name to begin with. Like, we're on code in those. Little bits. So let's just print our name to begin with. Let's just say Brian. So let's just print our name. Always think of these as smaller tasks. Don't be like, I got to write the whole thing at once. Let's just print our name. How do we print our name? What would we write? Give them over here. I was like some chill music here. Close. That'll do position, Abby. Abby, great answers. Don't worry if you get, just keep answering right here. Close. We're going to go to print, and then we need the word Abby. Does that make sense? There we go. We've printed Abby. We've printed it. I could print Brian right here, and that prints the word Brian. Now, there's no positions on this. That'll go to position Abby, but Abby as an object. So that says go to position object Abby. It's a lot going on right there in a very small thing, but don't worry about it. Keep practicing. We got this. And so here's what we're going to do. We're going to make this a tiny bit more complicated. I'm going to add one more thing inside of it. I'm going to go to paste. Now, I'll tell you why I'm doing this in a moment. I'm going to go to paste Brian, and this basically gives what looks like the same output. Now, the reason I'm going to paste is because I can add in a second what? By doing that, I'm putting in another what? What's the word for when we put another comma inside of a function? We're giving more instructions. We're saying we want to paste Brian, and then we're going to paste something else. And this is called the second what now, which you don't want to have with people. This is the second what in a function. If I put a comma in this, close argument. Abby, keep up the answers. You got this. This is an argument, more instructions. And actually, you might be thinking of how vectors work, that each value in a vector is a new argument. So when we create a vector with C, each one of those is the new argument of like, put this in the vector, and put this in the vector, and put this in the vector. This one says paste this, and then paste this. So the vector function uses different arguments to put things in a vector. The paste function uses different arguments to paste certain things together. So this says paste this, and then paste this, and just paste them together. So we now have a paste of Brian 1. I'm going to go here to print, and I'll show why in a second. It should work. And it basically looks the same. We're making this look really nice. But think about how my code would change right here. The first time it runs, it's going to print Brian 1. Can you just put in the chat, the second time it runs, it'll print what? Brian what? What will it print the second time the code runs? So my code will run print Brian 1, and then it'll print Brian 1. So it'll run the first time, Brian 1, and then it'll run the second time, print Brian what? So it'll run the second time, we'll say Brian this. What'll it do? And these are steps. Brian 2. Great job right there. More points. Give less answers for the right answer. Left points for the right answer. So it'll print Brian 2. And then it'll print Brian 3. Well, what about if we just say and call this number? Now, I want you to see this. I can now reassign this to number. And now it still prints Brian 1. Still prints Brian 2. Still prints Brian 3. Still prints Brian 4. Still prints Brian 5. So now I have a placeholder. And do you notice I went through a certain vector? So let's take a look. Let's identify different parts. First off, what is the vector I went through? Can you tell me the vector I went through? Just look at how I ran the code right here and tell me the vector I went through. Just tell me the vector I went through. So the vector means the values that were input for number. Like number took on the values of this through this. What values did I go through? What's the vector of things I went through as I ran my loop? And you can see the loop ran right here. You can see the iterations of it as I go through and I change what it is and I run the loop. I change what it is and I run the loop. I change what it is and I run the loop. I change what it is, I run the loop. 1 to 5, exactly. And then we can express that as 1 through 5 as the vector of values that the loop goes through. And so now, what is the name of my variable, which is just a placeholder? What is the placeholder that changes every time the loop runs? What was my name of my placeholder? What was the name of my placeholder that I used for every time my loop runs? This is the placeholder. It's just a spot for the thing. It's just a spot that every time this loop runs, it's just going to hold that place, and it changes. What did I call that placeholder? So I put in something that's kind of a thing that I can change number. So let's put the number right here. What line is my skeleton on? What line is my skeleton on? The skeleton is the code that doesn't change. We don't change the skeleton. The skeleton's inside the for loop. Oh, he's been here this whole time. There he is right there. There's our skeleton right there, just going crazy. I don't know why. He needs to be on here. I need to put an effect on here. 2 seconds while you think about what line has the skeleton on it. Oh, wait. I don't even know what this is. I shouldn't click this button. Oh, I think I know what it does. It says extra credit on the screen. Or it doesn't. So let's take over that button. 2 seconds right here. What line was it on? I'm going to make it so that let me double check. 52 is kind of the control panel for the loop. So if you look at the loop running down here, what line of code, if you see the line of code that did not ever change, what line of code never ever changed as we were running the for loop? What line of code never ever changed? So there's a line of code that never changed. And what line of code was that never ever changed? What line of code never changed? Line 56, great job. Line 56 is right here. And so with line 56, now watch this. Let's run the loop right here and see what happens. It works. So what we did is we made our skeleton, we figured out what values it would go through, and then we kind of tested it out by running it. Now what's great about this loop is you could just have it do whatever number you want, and you could do that right there. So if you notice, repetitive tasks are what we use for loops for. So, hey, Snea, so good to see you here. Congratulations on everything. Excellent work. So much going on. So good to see you. We're just going to do 100 points for random Snea right there. So good to see you. Oh, nice. Are they pretty useful, Snea? How useful are for loops for doing simulations, for different things? I should have had the guess word up from yesterday. My fiance, I was telling the story that my fiance guessed it like that. For loops are super powerful, and they're a really good skill set to practice. And they seem scary at first. Like, it's like, okay, wait, this loop how does it work? But we practice it, and we were bringing back Skeletor again this semester as we talk about for loops. So, full. Awesome work. A little more chill music right here. We're going to get the activity up and going. Snea, if you have questions, let me know. And Abigail, great work right there. Keep it up. Keep asking those questions. You're ahead of the game by checking this out right now. For loops are not the easiest thing, but once you learn them, you're like, wait a minute. This whole time, these weren't that bad. But if you don't know them, I'm not kidding. The first few times I practiced for loops, I would code some of the easiest for loops ever. I would code like print my name 5 times just to practice it. Like Snea said, it's like solving a puzzle. Like once you get it, you're like, yes, it works. Snea, I should show you. Do you want to see Snea really quick right here, and then we'll put a timestamp in this. I have permission from the student who's like, show it. Let me grab here we go. We've been working on like our first basic Shiny apps. And so Snea, check this out. You ready? I'm gonna open in browser right here. I gotta make sure I don't play this too loud. All right, let me turn off the music. So Snea, this is a preview of one of our first Shiny apps right here, and then we're gonna do Ella's question about the activity. I love this app right here. Here we go. Let's go check out the first Shiny app, one of our new creations this semester. Here we go. Okay, how many clicks in 5 seconds? I'm going to show you what it does when you click the start button. You ready? And I'm going to have to turn it down. Oh, no. Is it? No. It was working yesterday. Did it crash? Try it again. What? Oh, I'm in the wrong working directory. 2 seconds. 2 seconds. Set working. I was doing file. Let me close out RStudio. I changed my working directory. Now I'm opening to my working directory. Okay. Reset. Then we're going to do Ella's question right here. So open in browser. That was anticlimactic. Okay. Fixed. Here we go. I got to turn this down. You ready? It plays Final Countdown. So I clicked it 0 times. So our high score right now is like 54 from yesterday. Hey, Lucy. Oh, of course. Lucy's free to join. Oh, that'd be great. Tell Lucy she can join anytime. Here we go. I'm going to go for the high score. Oh, wait. I thought it wasn't working. I got to wait a second here. I got like 8 clicks or 15. Okay, one more try. I think I broke it. Well, we broke it. It's a lot of fun, and we're breaking it. I don't know why it's breaking, but... our session aborted. We just broke it. But it's a lot of fun right here. We sent it back and forth and worked on different things with the render UI. And so... oh, that's all right. You're always welcome to join in. Go back here. Okay. I'm turning the volume back up now. Okay, let's go over to Ella's question. Ella, thank you so much for waiting patiently as I show off that. I just had so much fun making that. Well, I helped make it and my student helped make it. Ella's question was... Wait, I saw Ella's question. She asked a question earlier. Using the tips data set, write a loop that finds the average tip for Saturday. So, okay, yeah, the tips data set. So is this one or yeah, yeah. Here's Snea. Message me on Discord and say send me that app. The student side can send it out and show it. Just say, Brian, send me that app. Just show me a quick message on Discord and I'll respond to it later with the app. But you can see it and debug the code and see how it all works with changing the colors. We're using like a rainbow palette to like change in a vector of rainbow colors. So and then randomly generate a rainbow colors using hexadecimal color generation code. So pretty fun stuff right there. Let's take a look at the activity. Okay, we're gonna hop over here. Thank you so much for waiting patiently, Ella. As you can tell, there we go. And I think is this question 3, Ella? Is this question number 3? I think it is, right? So let's go here. BAS, we're at 31, 25, BAS 320, okay. Activity 2, question 3. Let's go check this out. Here we go. I'm just going to realize. Awesome. Yeah, do it. You got this, Snea. Great work. Okay. So here's the thing. Someone's going to stop watching at this point. So we see right here we have library reg class. That loads the library. So all the library stuff is loading up. That's not error message. It's just telling you library's loading up. Then we have right here data tips. So that loads the tips data frame, which is inside the reg class library. I would take a moment just to delete a little bit of the text and see that it says reg class next to it that says this is coming from the reg class library. Now here's an important thing though. This is going to run aggregate, which tells us the values of y by x in the tips data frame running the function mean. You could find the standard deviations for those days. You could find the median for those days, all this really quickly, or you could find the mean for a day like Saturday. So you can actually confirm your answers right here for the work we're about to do. So there is the mean tip on Saturday from the aggregate function. But we want to work through this and try doing this with a for loop. We're basically doing repetitive work here to show that we can use a for loop. So what we want to do is we want to try to just get the tips for Saturday. And if we're going to get the tips for Saturday, we probably need a what of this tips data frame. If we only want Saturday, we probably want to take a what for like the data set. What do you think we should take of this data set if we want to take tips for Saturday? So we want to take a this of the data frame. What do you think we should take of the data frame? If we only want tips for Saturday, we should take a this of the data frame. Because I only want Saturday. I'm like, let me only take days that are Saturday. A subset, yeah. Let's go to subset. And the way I was typing, I don't even know where I was typing. We go to subset right here, and subset of the tips data frame. This will take the full data frame. This is 320. Yeah, we always try to up the game. No, but I think there's 474 stuff just like this too. This one's a huge file. If you have questions on more of these, we can definitely do more of these. So this right here doesn't really take a subset yet. We need to add an additional what, which is by a comma. We need to give it more arguments. Someone might have been saying it right there. We need to add more arguments by putting a comma. And the next thing, I usually hit enter right here, is write some conditions. The condition is going to be weekday, which says go to the weekday variable inside of here and get the ones that are equal to Saturday. So now we only have Saturday. Now, think about this though. It says it's missing with no defaults. Here's the code in the chat, Ella. Oops, delete that. Tell me if that works. You might have to send me a screenshot of it. Make sure everything's loaded in, like the tips data frame's loaded in. And then here, I'm going to delete these codes here in a second, but try those. Do those work? How's that? Does that code right there work? Copy paste that code. It might put in a little posture or a little dot at the start of it. Delete that off. But how's that code looking right there? There might have been a capitalization missing or something else missing, but that should do it. You might send me a screenshot if you have an error that it's showing. You might have to screenshot and send. I can look on the Discord. Did copy pasting that code in? Yeah, it's always the smallest thing, and that's a good thing. That's why we're here to practice. Be like, oh, extra parentheses. It's a problem. Was it on the weekday? Will that do that error? It does not. Yeah, an extra parentheses will cause all sorts of issues. So now here's the thing though. We just want the tip percentage vector. So what I like to say is this is now an object. I did it on tips. Is it supposed to be tips or tip percentage? And then make sure it's capital tips right here. Like make sure the tips is capitalized. And now we want this vector of information. We want to take this information. So when we take this information right here, how could we go to that column inside this subset? Like this subset's just a data frame. How could we go to positions inside of it? How could we say, okay, we have a subset object and we want to go to positions inside of it? Like, how could we go to positions inside this subset? So whenever I say positions, you'd be like, oh, to get positions like rows or columns or vector positions, we can use this sort of like things to go to positions. So how do we go to positions inside like a data frame? Like go to this position or this element or this row or this column. Like if I say go to row and column blank, you'd say, oh, we should put some little things there. There you go. Put some square brackets. So what I'm gonna do is I'm gonna go square brackets, and we're gonna take all the rows, but in the column space, and it'll read through these spaces. In the column space, we're gonna put the name tip percentage. So that says take all the rows, every single row of this subset, and then take the column tip percentage. So if you look right here, it's actually just a vector. Because what we're doing, this is not the subset, but we're just literally just getting this tip percentage vector for days that are only Friday. Does this code right here make sense so far, Ella? Like, yes or no in the chat. Does everything I've written right here, like, I'm taking a subset of the tips data frame, only days that are Saturday, and then I'm taking from that subset only the column tip percentage, which is then just a vector. It's because then it's just going to print it this way as a vector. If I took multiple columns, like if I said concatenate the column bill, and like, don't do this, I'm just showing. If I said take two vectors, we would get a data frame right here because now here's of the subset, the two vectors. So there is a tip and there is a tip percentage. Does it say to do tip? If it says to do tip, so let's say your question on your assignment might say tip. You could use select. Charlie, I'll do that. Great question, Charlie. I'll do that way of doing it here. I'll do a quick version, Charlie. 100 points, Charlie. We'll do it with some dplyr here in a second. I think I know what Charlie's getting at. I'll do it via that method, and I'll show an alternative solve that I could speed run here in a second. Great question, Charlie. 100 points right there. So if it does say take tip, maybe your question does, you could do that right there. And so actually, without even doing the for loop, here's the thing. If your question says to do tip, let's say it does, you could take this code right here and wrap it in something and put what in front of it to find the, I'm going to say it this way, the average tip. What could we put around our code right now and actually get the answer to our question? And we could also go here and change this to tip and run that to confirm answers. So you change that code right there. And what could we put around our code right here? You could put mean. And we confirm the answer. So we can see we're getting the same answer. But if we want to do this as a for loop, and we'll see Charlie's way of doing it here, thanks, Charlie. I think that's the way. I didn't want to do it because I haven't shown them dplyr in this class. We'll do it in 475. dplyr is a good way to like manipulate and select stuff in data and augment and do a lot of things. If we go right here, yeah, I had got that answer before I was started, but then I saw it said to use loop. If you had the answer, you have the answer, right? But no, we should know how to loop it. Hey, Kayla, good to see you here. Ask any questions you got. We should know how to loop this because here's the thing. Watch this. What do you think this is right here? What do you think should go right here? Let's go grab our words from earlier. Oh, did we lose it? Oh, no. I don't know where it went. Okay. We have three things we need. We need a skeleton, code that repeats. We need a variable, placeholder to change in the skeleton, and a vector values the placeholder goes through. So I usually like to call this something like capital day, and I've just created a what now. Like by calling it that, we have just created a what. By calling it that, we have just created a what. By calling it that, we have just kind of assigned it as the what. The skeleton. Yeah, no, Charlie, it's just practice. Nate was here earlier just saying it's practice. We created the skeleton. That's the skeleton. And watch this. day. I don't even know what I'm typing these days. Day, Friday, and that runs. Day, Saturday, and that runs. Great job, Kayla and everyone. Exactly. So what is the variable? Just the variable is this. Tell me what the variable is again, because Kayla's saying variable, so I think people see it. The variable is what? What is the variable right here? The variable is what? The variable is what? Let me say answer 3 blank vector. That initializes blank vector. So let's say create so what is the variable? The variable is what in this? So the variable is a placeholder to change in the skeleton. Well, so Saturday is part of the what? So the variable is a placeholder. Day is the placeholder that changes. And Saturday is part of the what? Because day becomes Thursday. It becomes Friday. It becomes Saturday. It becomes Sunday. Those values right there are the what that day goes through. So these are the values in the what. So this whole thing right here is the skeleton. So the skeleton is the code that repeats. This code will just repeat a whole bunch of times. And then the placeholder that changes inside the skeleton is going to be the variable. So that's what changes inside. That'll change each time it runs. And then the values it takes on are the vector that the placeholder goes through. Does that make sense right there? It's a good example, or at least the way we have it written right now without it being in a for loop breaks it down into its components, that we have a code that repeats. You notice I never changed this code right here. I'm only changing what is in the what. Brian is only changing what is assigned to the what. So see if you can answer that sentence. Brian is only changing right now what is assigned to the what. It's just repeating kind of what we've been practicing. Brian is only changing what is assigned to the what. That is correct, Charlie, on that. Brian is only changing what is assigned to the what. Brian is only changing what is assigned to the what. Because the skeleton's not changing down there. I'm only changing what is assigned to the what. To the variable. Exactly, Ella. The variable gets a different assignment each time the loop runs. It moves through the elements of the vector. So to write our for loop, we're going to go here and say FOR. And I'm going to do this in an easier way right here. I'm going to say print. And just for a moment, we're going to do it this way. Just to see this. We're going to go print and just print what this does each time so we can see the answer. We're going to change what it does here in a moment. And frankly, we could solve it this way, but it will do it in a nicer way. Let's take the vector, and this is a good way to see it, Thursday, Friday, Saturday, Sunday. We're kind of like watching what this does, and let's take our thing here. The first time this loop runs. Awesome, Snea. Great senior year. The first time my loop runs, ignore the rest of this code now. The first time my loop runs, day will become what? The first time my loop runs, day will become what? The first time my loop runs, day will become what? This is a decent way to answer the question. First time my loop runs, day will become this. It'll be like, okay, day is this, run the code. It'll become Thursday. Then it runs this code right here where day is Thursday. Then it assigns day to Friday, and then it runs this code. Then it assigns day to Saturday, and then it runs this code. What is never, ever, 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 ever changing? What never changes in our code? What never changes? You could do it with that also, but you'd make sure you save as a subset. You'd have to do as a subset. If you do tips, you're taking the full data set. There are ways to do it that way, though. There are ways. If you want to send me your code, there are tons of solves to this. And I'm going to show Charlie's kind of way of solving it here in a second. So what never changes in your code is I run through this, and it changes Thursday to day, or day to Thursday, and then runs this, changes day to Friday, then runs this. What is never changing in the code every time? Skeleton never changes. The skeleton never changes. The skeleton, great job right there, William, earning everyone some 100 points. Day is changing every time it runs, because how many times will this loop run? So another question, how many times does this loop run right here? And don't worry, this is our practice. How many times does this loop run? So this loop will run how many times? And then we'll do a better solve of this. How many times does this loop run? Close, Ella, close. It'll run 4 times, right? So what it does is it assigns Thursday to day, and then it runs the code, and then it comes back up here. Then it assigns day is going to be Friday, and then it runs the code. And so then it runs the code down here. Then it runs this right here. It says, okay, now day is Saturday. Then it runs this code. And so you see the skeleton never changes. Great job, William. Excellent work. We're going to make William a mod. You bet, James. We'll do question 7 next. And so if you notice right here, it runs it 4 times. So this will actually print the answer, and we could see the answer as the third answer. We're going to make this look a little bit better, though. Here's how. We have to create a spot to store our answers. And this is a really neat thing we can do, is we could take the mean. We're just going to remove where we had the print around it. And then let's go here to answer and go to position day. Now, you might not think this would work, but this will actually store into position Thursday, position Friday, position Saturday, position Sunday. And when we run this right here, it'll actually create in our vector those named positions. So now we're storing into the vector into position Thursday, but position Thursday doesn't exist. So it creates position Thursday as position 1. Now, this is a pretty great way to solve it because you can see the answers in order. Now, what we could have done, this is another alternative solve to it, is we could have also went and said levels of tips $ weekday, and the levels are going to be the levels. Now, this is an okay solve too. When you get the answers, they're not in order though. They don't go Thursday, Friday, Saturday, Sunday. But it's going to go through the levels right here. Make sure to use levels. That works best. But this is the levels right here. So it'll say, okay, the first time it runs, it becomes Friday, then Saturday, then Sunday, then Thursday. Before I do the alternative solve, how does this look, Ella? Does this make more sense right here? The answer now would give the column names above it or the day name above it. Rather than us printing the answers and then being like, okay, the third one's the one I want, we could get the answers printed right here, and we could do it for tips or tip percentage, whatever variable we want. We could just literally change this to tip percentage right here. And then when we run it now, we would get the tip percentages for those days. So we can just change whatever variable we want. We can change this to bill, and then we could just store for bill for those days and run the loop. Yes. So yeah, the levels is what will do it. So make sure you do levels, and then that's the different values we'll go through for the weekday. So to Charlie's question right here, we'll do a quick speed run of that, and then we'll do question 7. Thank you so much, James, for swinging by. More questions. We only have that question on the list of questions. So after James' question, it's complete open questions. We're going to do Charlie's speed run version of this. Charlie was saying, let's take the tips data frame and use dplyr methods. If you're doing this, you must use library dplyr. As I just hiccup. And so there's dplyr. Make sure to install packages. dplyr. And so this is like a data manipulation package. We're going to say filter weekday. We're inside of it. Good. I love that it does that. Equals Saturday. And now we've just selected Saturday only. Whoops. Hitting the wrong lines. Just go enter right there. Go new pipe and select equals tip percentage. There it is right there. Oh, I didn't type select. There's the tip percentage. And then let's go here and do summarize. And can we just say mean? No, it doesn't like that. Mean equals mean. No, I always forget how to use summarize. Summarize is always one of those ones that summarize in dplyr. I always get the syntax of it wrong. 2 seconds as I look up how to use summarize again. Summarize. Oh, we got to put the name of the variable? Well, then we should just go right here and do this. Mean. There we go. There's the value of the mean. And so that should be right there. And so you have to put the, for the activity, but I put the answer wasn't right for the activity, but I put, let me check that out here in a second, Ella. Good questions right there. Class in 1 hour. So this right here is the methodology for doing the what? What did I just create right here? What do you think I just created? Hint, we can do this for any day right here. If we go Friday, Saturday, what did I just create right here, which is still the same thing? So I just created a what? We just did a different method for creating our what. Like someone might have done this solve right here to create it. We've just created a what to use because we're just going to do it for different days now. So all we're doing is just trying to get it. We created the skeleton. Ella, great job right there. We created the skeleton. And so this is going to go inside our loop. And we'll go here to FOR, type our for loop, drop our skeleton in, and we'll store it as answer 3 again in position day. And so we'll go here to day. It might have a little bit of an issue. We'll see what it does. Go away. Good. Variable is day once again. The vector is the same vector we're going through. Does it like it? Does it like it? There's one last thing I might need to do to this. It's a little bit longer, so... Oh, might have worked. It does it as a list. It changed it to a list, which is not the end of the world. Interesting that it did that. I think I know how to... What I would do right here is I'd go to this and I'd go as numeric and take everything we do as a numeric. So I would, forgot to close that parentheses. So I would do that. There we go. Now we get the same. Oh. What I did was I didn't put the placeholder in. That's a common mistake. Go too quick, forget something. Gotta look at your output. And there we go. So that is that. You could also reorder this vector right here by going to positions. We want Thursday first, then Friday, Saturday, Sunday, and there's the reordering of the vector. And then you could overwrite the vector with these values so that you see it, and that's a good thing of this. Don't worry, we're just trying some new things. Just being like, okay, let's rewrite our vector and reorder it. So we could reorder the vector by this and save over the vector with those ordered versions that we know as Thursday, Friday, Saturday, Sunday. And this was just an alternative solve. So try using different methods, try different ways of doing it. And let me look right there, Ella, at that. Then we'll do question 7 on activity. Thank you, James, for swinging by. We have one more question on the docket so far. I'm going to take a look at question 7 right here, or Ella's thing. It said you were wrong, Ella. Let me go look. Wait. Oh, Ella, are you not in our section? Let's see right here. Might not be. Let me go look at the activity. Wait, where is it? There's activity 1. Okay, let me go find this. Thank you for being here, Ella. Keep asking the questions. What are the write-ups and visualizations supposed to look like? Great question, Jackson. We can do some visualization write-ups. I'm gonna take a look at this. Yesterday, I'm gonna cough. Yesterday during office hours, we did a really good review of visualization 2, and I've got a thing on it. So let me know if this doesn't answer your question, but we kind of walk through and talk through. So I'm gonna drop this in the chat right here, Jackson. Oh, that's totally fine, Ella. Viz 2. Check out that right there. That should be a link to visualization 2. And let me go look at that question, Ella, and see if I agree with the thing on it. Okay, I need to find it. Oh, you're on for loop 1. 2 seconds. I was on the wrong one. Oh, yeah. I swear. Well, one of these days I'll sleep. Okay. Questions. Okay, for loop. Gotta go to the question bank. Using the tips daily loop, find the average tip for Saturday. Is it right? Oh, okay. Ella, it should be tip percentage. I need to email instructors and say, or we need to put an alternative solve. Give me a second right here, Ella. I need to find the answer to that question. What it was. Ella, it should be tip percentage. That is an error. I'm fixing it for my class. I'm going to email instructors to say for Saturday. Okay, Saturday. Okay. It should say tip percentage, Ella. I'm updating it for my class. And so let me go back to, okay, I think that should be updated, and I need to update. So Ella, do tip percentage. Do tip percentage. Tip percentage. And let me see if it updated from my class. These things are so weird sometimes. Like you do like update and it doesn't update. Do tip percentage. And let me send this to the instructors. And then we're going to do question 7. Okay, wait. Higgins. Okay, 2 seconds. I'm going to send the instructors. 2 seconds. Panel. Okay. DS220. Activity. Okay, sent to instructors. Got it. Good to go. Sorry about that. Awesome. Great work there, Ella. Excellent work. You're welcome. Nice job. I am RSU is pretty. Oh, William, so glad to hear that, William. Thank you so much. Well, we got question number 7. I think it's from the activity, right? Thank you so much. I'm so glad to hear that. William, glad to have you here. We're making sure we try to do as much communication as possible. Communication is what is key. So we got question 7 right here. Ooh, looks fun. Let's take a look at this. Question number 7. Okay, let me take a timestamp. 56, 37, BS through 20, activity 2. Question 7. Here we go. Okay, with question 7, the command sample, it was on here for a second. The command sample is going to sample from the vector x of a size of n and replace the elements. Okay, cool. At random. Using a for loop, generate the lifetime values total spent by 50,000 customers and make a histogram of these results. What is the overall, so we're going to do this right here. What is the overall average lifetime value? You'll want to follow these best practices. Cool. Imagine that over a customer's lifetime, they either make 1, 2, or 10 purchases, ... Okay, so here's what let's do first. Let's first create a vector of possible purchases. So William, how could we create a vector of values that customers could purchase, like 1 to 10? So I just want to store into the, or was it Jackson? Oh, no, it wasn't Jackson, it was James. James, how could I create, because James asked, how could I create something called purchase with the values 1 through 10 in it, or purchases? So I want to create something called purchases. Let's say here, Q7 start. I want to create something called purchases with the values 1 through 10 in it. I want to create something called purchases with the values 1 through 10 in it. So I'm just trying to tell you what I like. I want this thing called purchases, and I want it to have the values of 1 through 10 in it. So we don't have anything in our environment anymore. Sure, Adam, definitely. I teach 475, so of course. Kayla, so close. Kayla, so close. Kayla, 100 points, so close. Just don't add the positions on it. And both of your answers, kind of put those together. James and Kayla, great answers right there. We're going to create right here, I'm going to call it capital purchases. We're going to store into it the vector 1 through 10. We could have also done this the long way, which is quite fine, of doing this right here. Not too long, but this will achieve the same goal, but it's much quicker to just go right here. Or you could have done a sequence. Like another alternative solve would be this right there. All these answers are valid answers. The whole goal is just to get that purchase thing over there. So great work. And so we're not calling positions on it. We're just saying store the vector 1 to 10 into purchases. Now it's the practice. You're going to see, like, you start to get it down. You do it 50 times. You're like, psh, every time we say we make a vector, we're talking about just use the colon right there. So now we have the purchases. For all intents and purposes, it can be picked at random. Each purchase results in a customer spending either 5. Ooh. So what do you think we're going to need for this? Tell me a 3-letter word. Let's make a what for that. So let's say spent. So I'm going to create this object spent, and we should probably store into it a what? So we should probably store into it a what? We should probably store into it a what? What should we store into that? So it goes 5, 5.5, 6, 6.5, a sequence, yup. So it'll go from equals 5, that's the starting number. 2 equals 20, that's the ending number. Now that's not right because it doesn't do the by. Now we go here to by and say by equals 0.5. Exactly, Kayla and James right there. Perfect work. So now we see the sequence. Make sure you take a look at what you create and what's what you want. Now we need to generate 50,000 customers. How many customers do you think we should generate first? We need to generate 50,000, I think it was. How many customers do you think we should generate first? So we got to do 50,000, was it? Where's the says how many customers? 50,000. How many customers do you think we should generate first? We got to do 50,000. How many do you think we should do first? How many customers do you think we should do first? Let's call right here. Let's make a vector called, so we need to start a vector to store our results into. Let's create a vector called lifetime value and just store nothing in it. 10's a good. Good to see you here, Nolan. Go smaller than 10. 10's a lot. 10's a lot. How do you think we should do first? Less than 50K. That's a great. I like both answers. I would say we should do less than 50K to start. Let's go very simple. Start very simple. Start very simple. How many do you think we should do first? Kind of a hint with that first thing. So as we always do if we make a for loop, before writing the full for loop to go 50,000 times, how many times do you think we should do it to start? Yep, we'll be completing that during class, Adam. I'll be going through the steps too, practicing and doing a lot of the best practices. Go smaller than 5. Let's just do 1. Let's just do 1. Does that make sense? If we can do it on 1, then that will become our skeleton. There he's right there. He's too excited. He's excited. Once we write that skeleton, it's awesome. No, 1's the answer. Let's just make it work on 1. Because if we can find the lifetime value of 1 customer, then we'll just repeat the process. Does that make sense, Kayla, right there? If we can find the lifetime value of 1 customer, then we'll just do the same thing to find the lifetime value of the next customer and the next one and the next one and the next one. And that literally becomes our skeleton for finding the lifetime value of customers. So we're now going to try to write a skeleton to find the lifetime value. So what do you think we should first do? Brian is a customer. We'll make a random amount of purchases. So now we should figure out how many what's Brian makes. So we just have Brian right here. Brian's going to make a random amount of purchases. What would you like to know right now? We are going to do it multiple times. Yep. Well, we're going to first just do it for 1 customer. So Brian's our customer. What would you like to know? What would you like to know right now about the customer right here? Like we have your customer and what would you like to know about that customer? What would you like to know about that customer? Kind of in the name of the word. How many purchases? So we should probably what the purchase vector. So we should probably do what on the purchases vector. So we should probably do what on the purchases vector. Well, we'll figure out how much they spend. Imagine they're coming to our store, so we're going to ask how many purchases do they make. So we should probably take a what sample. What sample of that purchase vector? Brian made how many purchases? Brian walked into our store and made how many purchases? Brian walked into our store and made how many purchases? So this is just Brian walked into our store and he made, over the lifetime of coming into our store, he made how many purchases? This is just Brian. Just Brian walked in. How many purchases did he make? I'll show the thing a little bit more. I see it. Not 2. I mean, not 1. How many purchases did Brian make? Don't worry about the L. It just means integer. So it's just the value of 2. So that's just the value of 2. If that L confuses anybody, not 10. Brian walked in and Brian made how many purchases? Like, this is just a different Brian. He made 2 previously, correct. And then I reran it. Darren walked in and made 8 purchases. Emily walked in and made 7 purchases. So what is this code doing for us right here? You don't need, the L might confuse people. It just means integer. That's how R sees it. It's still just a number. So I changed it to numeric. So it just says 7 up there so you can see it. But don't worry about I took off the amount. 1, there we go. That's 7 purchases, 2, 9. This is just different customers coming in. No, don't worry. You're doing great. 100 points. You got this. That's exactly what we want to do, is just practice and be like, okay, that's what it's storing. And then we just practice. It's like, oh, look at that up there, because it's what we just created. So now we know Brian made 3 purchases, but then what would you ask me about those purchases if we want to find out like what their lifetime value is? What would you want to find out about those purchases? What would you want to find out about those purchases? So Brian walked in, maybe I bought 3 sticks of gum. Walked in, bought a stick of gum for 5 cents, another stick of gum, another stick of gum. Maybe I was buying plasma TVs back in 2020, 2012 or whatever. I don't know what year plasmas came out. The cost of those purchases, right? So now, and this is the complicated one, I think, for a lot of people. We've got right here a vector of spent. So we need to go and sample the vector of spent, which is just how much someone spent at our store, right? This is just a vector of spent. And so now we need to sample from it the amount of purchases I made. So this is the amount of purchases. And then we need replace equals true. So if you notice right here, oh, do we only have, I thought there was, oh, we need to sample how many purchases I made. There we go. How expensive they are. So Brian made 3 purchases. The first purchase cost him $6.50. Next one cost him $20. Very expensive at our store because that's the highest price items we have. The next one cost him $15.50. Does this make sense right here? Like if you watch this code right here, this customer made 1 purchase that cost him $18. Look up their customer purchase to see what it comes out to. This customer made 5 purchases, and there's the purchases that that customer made. So what replace does, like if you say, imagine you say to your kids, we've got here, you can get a blue shirt or a green shirt. So you say to your kids, blue or green shirts. So let's say shirts, and you say colors are blue or green. And if you go here to sample the shirts, well, you could only sample 2 shirts because there's only 2 shirts to sample from. It gets mad if you try to sample more. But if you say replace equals true, well, now you could actually get 2 blue shirts because there's a 50-50 probability right here that you get a blue shirt or a green shirt. But you now with replace equals true, you can sample the blue shirt. And then if you took the blue shirt, you could take it again. So replace equals true allows for the same value to be picked twice. We might see it in this vector because it's kind of long. I don't see it. You might eventually see that the value is used twice because the value can be sampled again. So when it's true, it means that there could be, like, I'll show, hopefully we get one where it shows. Oh, here we go. With replace equals true, someone could spend $10 on an item and then spend $10 on another item. If we do replace equals false, then once you spend $10 on an item, you can't buy another item that's $10 because that's already been sampled as a possible value. It's just that the probabilities are equally spaced for all of these. So I think Kayla's here right there. And great job. Good questions. Like, what does replace equals true mean? It means we can sample it multiple times. And so we see this in this vector where 10 was sampled multiple times. It comes into play when you have things like this where you need to put replace equals true on. So we have right here is customer spent. What do you think we want to find for how much that customer spent? Like I go right here to the customer spent and find the what of what they spent. So what do you think I want to find for what that customer spent? What do you think I want to find? Because I want to find like how much they spent. So I should find the what for that customer's spending. So what do you think I should find for what the customer spent? We could find average. We could find mean. So we could find out what was the mean purchase of that customer. We want to find their lifetime value. So is the lifetime value of a customer their average purchasing or there's something else purchasing? Like we talk about how much this customer was worth to us. So we wouldn't want to find the mean of their purchases. We'd want to find how much they purchased. Sum. Exactly, Kayla. Great work. We don't want to find the sum of their purchases. And that was the lifetime value of that customer. So now we can make our code happen multiple times. Great to see you here, Ashton. So right here, our code only produces one output, right? What did we just create? What did we just create with this code that can run like this? That I can just keep generating customers. I'm going to generate 50,000 customers unless someone tells me what I created. I'm just here. I'll probably generate a good 40, 50 customers. There's the lifetime value of another one. That one was worth $125.50. That one was $50.50, $114. I'll just keep generating customers and writing these down as I do it. So I'll just keep doing this right here. I'll just keep generating customers. What have I created? Oh, we are reconnected. Well, we probably want to take the answers we're getting right here and store them. If I'm generating for the first customer, now we generate this, and we now have the lifetime value of the first customer. And Kayla, that was 100% right. Let's throw 100 points out there. That's 100% right. Now I have the second customer. Wait a minute. This is kind of customer ID. Customer ID could be my what? So customer ID could be my what right here. So remember the terminology. The skeleton is the code that does not change. Inside the skeleton is a this that's a placeholder for what we change that it will take on different values. The skeleton does it. So what is the placeholder thing called? I just created a placeholder that will change inside the skeleton. Now, the skeleton doesn't change, the variable. The variable is customer ID. So let's go ahead and write FOR. Remember to write your for loops this way, and then put your skeleton inside of here. We've already figured out you can highlight code and press Control-I to reformat. And so now we have our placeholder, which is changing, but it needs values to go through. What values do you think I'll go through? We're so close. What value do you think I'll go through right here? What values do you think I'll go through? When I do this right here, my code should go through what values? Well, think about it. We're talking about customers we're generating, right? So I need to generate the first customer, the second, the third, the fourth, because that's what my code does. It just changes which customer I'm generating. If you look right here, this will change to a different customer stored into. So I need to generate the first, then the second, then the third, and just keep going until I generate all the customers. So what does it need to go through? It needs to go through the first and the second and the third and all the way to the 50,000th. So what vector should it go through? Kind of, that would do, I could do that. Now, if we did that, we'd have to go right here and do this. That's not enough. You're on the right track. That'll generate for me 10 customers. And if you look right here, if you go to lifetime values, we generated 10 customers. So we got 10 customers generated. We need to go to 50,000 though, so that's going to take a while. You see now we generated 14 customers. You see lifetime value is getting bigger because every time it runs, it's putting one. Oh, yep. Kale, 100 points, you got it. So let's just put right here the vector 1 through 50,000. Now it took a second, but it did it. It just generated 50,000 customers that quickly. 50,000 customers generated for us because all it did was rerun that code 50,000 times. Every time it runs the code, it changes what the customer ID is, which is just our variable in the loop, which changes kind of where we're storing. That's what the variable is purposely doing right here. It's saying store into lifetime value into position customer ID. Yeah, and so we're changing the customer we're generating for because we need to generate 50,000 customers. So the customer ID is what we're changing. We're saying, okay, run this and store for the first customer. Run this and then store for the second customer. Like purchase, yeah. And so we're not just doing 10 purchases. We're doing generate the first customer's lifetime value, generate the second customer's lifetime value, generate the third customer's lifetime value. And remember how we started? Really good practice. We generated only one customer's lifetime value, and then we just looped that code to do it for 50,000 customers. Kayla, I want to say something to you, and this is so big, like to the whole class. I wish the class was here right now. Dr. Petrie made up a lot of these things that we're doing right here. He made this one up about 2 years ago, because I know when I was doing this one and when I was trying this one on my own. 3 of these activities on my own on the playlist, like on the plane trip. I think it was like a 2-hour plane trip. So this one alone, the first time I did it without practice or anything, because now I can code it like that. I think the first time I did it, Kayla, it probably took me about 45 or 50 minutes. And now we can talk through it. And I just want you to know that. So we talked through this in less than 20 minutes. And the first time I did it on my own, like straight trying to solve it without any help, without any practice on it. Like I've done for loops, obviously, but not like the more you practice, the better you get. So imagine, like the first time I tried to solve this, 1, I was able to solve it. But 2, I ran into problems and I had issues and I was like, oh, what's wrong with this? And I'm debugging my code. But now I could probably, if you asked me to sit down and write the code for this, I could probably write it in 2 minutes maybe. But once you know solves for stuff, you see it. But don't worry about like being able to know the solve for everything. Worry about the process. That's my advice to everybody here is worry about the process. Now we can just make the histogram of it, of not customer ID, of lifetime value. Worry about the process. And let me state this. What are the 3 important things to know for our for loop? Aw, you got this. You got this. Yeah. No, just swing by office hours and say, how do we solve this? What does this mean? What are the 3 things we have to know for our for loop? What are the 3 things that we should understand conceptually what these are at each time? Because understanding them conceptually, and we have, if someone wants to drop another question, we definitely have time for another one. We'll probably do one more here. What are the 3 things we need to know? Like we need to know what these mean and how they're used each time and how we create them and kind of in order to create them. And then we just have to be very exact in what we do. It drives you crazy if something doesn't work. You're like, what is going on? The 3 things we must know for our for loop would be the blank, the blank, and the blank. And I've got them all listed right there. The skeleton, the variable, and the vector. So try writing this right now. You ready? This is how I practiced writing my for loops at the very start. try printing to the screen. We'll give it a second here. We'll do like a 1 minute or 2 minute test. You ready? Try writing a for loop that prints to the screen the numbers 1 through 10. Try it, Kayla, right now. So I'm gonna give you tips. I'm not gonna write anything. When you write your for loop, I'm not gonna write this. What do you do to start writing a for loop? If you want to create a for loop, what should you do? These are the steps. So write a for loop that prints to the screen the numbers 1 through 10. When you write a for loop, what are you gonna write first to begin with? I'm not gonna write anything. I'm gonna have you write it, and I'm gonna have you make this for loop that works. I'm just gonna instruct you through it. What are you gonna write to like start writing your for loop? Like, what's the code to like bring up a for loop? To create something that we can work with. Don't type too much. Just get the basics on the screen. What would we do? FOR. I think I should hit enter. So now what we would do is create a skeleton. A skeleton, let's create it by just doing a static thing. I said I want the numbers 1 through 10. So what should you think? If we want to print the numbers 1 through 10, what do you think we should do to start? This is just the theory. What do you think we should do to start if we want to print the numbers 1 through 10? But don't write the full thing right now. I just want something. Let's start out. So we want to print the numbers 1 through 10. So let's start at the very beginning. What do you think we could write down here to print the numbers 1 through 10? We got this. So what do you think we could write? I think you might have the full thing. Okay, yeah. That does work. That is correct. That is correct. So that you have identified a placeholder. Okay, I'm not slowing you down. You got this. Nothing is wrong. So what do you need right now? What do you need right now? You're almost there. Done it some time limit. You're one step away. You literally kill. That's 100 points. I don't care. That's amazing. Like, you did it. You're on the right track if you understand that and can do it. What I was going to have us do is I was going to have us go down here. I was going to do it in more steps. I was going to go to print 1, and then we could go down here and say number save into 1. And then this right here, we could replace this, showing that we can just use that as a placeholder. And then this is identified as the skeleton. Because now we have a placeholder. So this would be the variable. And whatever values this goes through is the vector. So this, yeah, you just did it in 2 minutes. I'm not even joking. That's how I would practice and make sure I could do things like this. Like understanding how it works, where things go. But you're understanding this is the thing that changes in the code. These are the values it goes through. That's the rudimentary understanding. And then questions just can get complex on the things they ask you to do. But you always have to break it down into parts. Like, let's generate a single customer. Let's generate their values. Like, the theory behind the for loop is not often the hardest part. Sometimes, like, what does the question want us to do is the harder part. Like, I have to generate this customer with these values. So the harder part of this question was really this. It's just, if we said generate 50,000 customers, well, the vector should be, we're going to generate the first customer up to the 50,000 customer. And then we just need, like, what customer are we generating? I think this right here would be the obvious part. Like, we need to store the lifetime value of the first customer. And then we just have to create that value right there. So a little tougher. And Caleb, we got about 10 more minutes. What else should we do? What other questions are there? See right here, my phone's just going for 30 minutes. Pokemon's got crazy stuff. What questions are there? We'll head back to the main screen. Might grab some lunch here in a moment. Let's see. If you have questions, let me know. Did some good work today. Good practice of for loops. A lot of for loop stuff today. For loops are tricky, but they're so valuable. If you heard from Snea earlier, she was saying how she uses for loops for Monte Carlo. Is there any short answer questions here? Yeah, let's see that. Let's try to do a short one right here. Let's find one that we haven't done. I might do one of my favorite ones. This is probably one of my favorite ones. Let's see how quickly I can solve it. We got 10 minutes. This is a tough one. One of the other ones, I think this one I didn't get solved on the plane. I remember that plane trip. Best way to find tips under Friday under 10%? Oh. So you want to use a logical right there, Adam. Oh, is that... Gotta go get someone... Oh, no, let's do... I want to do this one. Adam, post the... So if you want to find tips for Friday under 10%, you want to do a logical. So you want to make sure to check You want to subset Friday. Check out earlier where we're subsetting Friday. And then subset Friday. And then look at the day's Friday and find out if the tips are less than or equal to 10%. So, and Adam, definitely have a follow-up on that if you're wondering. But take a subset. Are we actually doing activity 3? We did it last week. So we did the for loops yesterday. KP, great to see you here. We did a full video on it. I'm gonna do a kind of a speed run of a question right here. Pretty fun one of my favorite ones. Were you able to see the video yesterday? There is a full video walking through most of it, a lot of it. It's just a very big activity. So we did a lot of it, and I can always take more questions. Maybe kind of a speed one. Yeah, you got it, Adam. Tell me if you need more help on it. You got it. Subset for only days that are Friday, and then find out the tips that are less than 10% for that day. You got this. Let's take a look at number 12. This was a really interesting one, KP. One of my favorite ones. And here we go, BS 320, activity 2, and question 12. Probably one of my favorite ones. Let's go check this out. Here we go. There's a line of 50,000 switches. Each is initially on. One by one, 250,000 people flip some of the switches. What? Okay, wait. Is that the right number? 250,000 people. Let's... Person 1 flips switch 1. Person 2 flips switch 4, 6, 8. Person 3 flips this right here. I think these numbers are off right here. That should be 50,000. There we go. And they're going to keep flipping these switches. In other words, after one by one flips off the sequence. Here we go right here. Very important stuff. Your goal is to determine which ones are still on. Oh, is this one... Are you looking at activity? I don't think we're on activity 3. Okay, let me double check, KP. You're looking at activity 3, right? Activity 3 is associations part 1, which we'll be doing one next week for this. So are you looking at the associations one, KP? If you're looking at the associations one, we'll be doing an activity for that next week. So or jump by office hours a little bit later today, and I could do some of that if you'd like. Yes. I guess it's already... When does that due for you, KP? I'm assuming, because I haven't published it for our section yet. When does your section show that it's due? Now, what this question is doing right here is this is actually prime numbers. Because if someone's flipping off this Sunday... Activity 3? Which section? How could they be there? That's interesting that they have it do that quick. Ours is not due until Friday the following week. Ooh. Oh, you could be looking at assignment. Oh, okay. Yeah, KP, let me know if it's the assignment. And I think it's assignment, right? I think it's assignment. Is it assignment? I think it's assignment, right? Kayla, 100 points. Thank you so much. I'm pretty sure it's assignment, right? Sorry, we've been doing activity. KP might not even have said activity. I might have assumed activity. But yeah, we've been doing some assignment today. We did some earlier ones. So we did getting started, and we did question 1 also. Jump in the office hours a little bit later, and we'll check out more. Let me know, because I think you're looking at the for loop assignment, right? We did the first question on the assignment today. So check those out, because I'm assuming for loops, right? KP, assignment 3 for loops. So let me know. Yeah, awesome. So with the for loops right here, this is prime numbers basically. And this right here, in other words, after person 1, they flip off these sequences. And this right here is basically your skeleton. Yeah. Might want to change the names, activity assignment. Yeah, we should maybe call it homework or something. I think Caleb makes a good point right there. Let's say Q12. Oh, remember, don't put full answers in the chat. That looks about right. Remember, don't put full answers in the chat. So I'm just remembering. It looks kind of right. DM me it on Discord if you want to DM me a full answer. DM me a full answer on Discord if you want. Remember, don't put full answers in the chat. Just so people don't grab full answers, because we don't try to send full code. I mean, I do code stuff here, but you still have to type it out. We just don't want people maybe joining in and copy pasting. Sometimes I'll send, no, don't worry. That's obviously I write a lot of code here and I write a lot of answers. So people might be like, well, Ryan just shows the answers. Still got to write it out. Still got to practice it. And it's pretty much the only way to teach online is to show the examples and to walk through it. So we're kind of in that boat of, well, got to show the answer some way. This right here looks to me like something I should change. So let's try this right here and just go I save into 2. That generates the sequence of these numbers. So that's the pretty much the first person, except for person 1. They're kind of unique. Let's go here and call this lights. And let's just generate a sequence of lights. And let's go to rep and go to on for all the lights and rep it 50,000 times. And there's our 50,000 lights that are on. So what we want to actually do is we want to go in and store into these positions in lights. I'm going to store into those positions because there's the positions on lights. Cool. We want to store into those positions off. And now we should see all the ones. Awesome. I'll check it out a little bit later. Great work, Adam. So now we've turned off all those lights. This question I thought was crazy difficult, but here's the thing. We just created pretty much everything. The only thing we didn't do is the first person's kind of unique. They just turn off the first light. So let's write that first person's code right here by going to position 1 and turning off the first light. We should also put our code in order right here because we need to create the light sequence, turn off the first light, and then algorithmically turn off the lights going from person 2 to person, oh, there was an extra 0 on that. It should be, no, maybe it was right, yeah, because this person will turn off light. That is correct. That was correct. Oh, well, darn it. It's just the comma right there. Didn't see it. Because they're going to turn off light 500,000. The I is the person. So person 1 walks in and turns off the first light. Person 2 walks in and turns off the light 4, 6, 8, yada, yada. They turn off all the even lights, all the lights divisible by 2. Person 3 walks in and turns off all the lights divisible by 3. Person 4 walks in and turns off all the lights divisible by 8, or by 4, which is just things that are divisible by 4. So we basically wrote it right here by saying person 2 walks in, turns off these lights. Person 3 walks in, turns off these lights. Kayla, what is this thing down here? This one looks really super complicated, but we just wrote the what for this. I think we've solved it. This question right here, I was like, this is really, really tough. I was like, how do I do this? I was on the plane. I was like, oh my gosh. But we just wrote the what right there because I'm showing it by not changing it. I'm just changing the placeholder variable with a vector of numbers it's going through. I've just created my what? I've just created that. And what is that? What is that thing right there? The thing inside the for loop. It's inside the for loop. So it's inside the for loop. That's the skeleton. Great work right there. That's the skeleton. And the skeleton uses the variable I, and it goes through the vector that. Because those are the people who walk in. We go through that many people. And the first person is kind of unique because the first person just turns off light 1. They don't follow the pattern. Notice how they just turn off light 1. So I did the work for the first person right here. They're unique. The remaining people follow the sequence as it says right here for each individual. I think we've done it. So we go right here and we run the code, not a parentheses. Oh, what's going to be bad if I do that? And now we've turned off the lights, I believe, and we can see what lights are on. So now you can see certain lights are still on. And here's what's interesting. If you look at which lights are on, the positions of the lights that are on. Which lights equals on. I did it this way. So now let's go to the head of the sequence. What do you notice about these numbers? Hint, they're numbers that were not divisible by 2, 3, 4, 5, 6, 7, 8, 9, 10. It automatically writes that when you write 4. You start to remember what to do, but even I just use the 4. I like type FOR, then I hit enter and let it autocomplete. What are those numbers right there? These are numbers that are not divisible by any other numbers because there were lights that didn't get turned off. They weren't divisible by 2 or 3 or 4. Like 2, even though it's divisible by itself, it has no other things it's divisible by. So 2 is only divisible by itself, and 1, which everything is. 2 is only divisible by itself, 3 is only divisible by itself, 5, 7, 11, because we would have turned off the light if it was divisible by 3 or 4 or 5. What did we just find right here? What does this question actually ask you to create? It actually asked you to create the whats by doing this. You've just created all or a bunch of whats, or you found them. You can confirm the first 100 of these. So these are numbers that are only divisible by themselves in 1. These are all prime numbers. So what we did right here is we just found prime numbers because we said turn off the ones that are divisible by 2, turn off the ones that are divisible by 3. You notice there's no even numbers here because any even number is divisible by 2. There's no number that ends in 0 because any number divisible by 0 would be by 5 or 10 divisible. So you can see these are all prime numbers because that's what this sequence does. It goes in and turns off anything divisible by 2, anything divisible by 3, anything divisible by 4, and then we just change which one right here. So we're just changing what it's divisible by, saying the second person is turning off things divisible by 2, the third person is turning off things divisible by 3, the fourth person is turning off things divisible by 4. I think this question I didn't solve for the first time on my own. I think I had to go to Petrie and say, what am I doing wrong? Yeah. Oh no, it's just finding prime numbers. But when you think about how we have to practice and learn these things, it's pretty tough the first time. This question I can now theoretically get every time very quickly, maybe because I've solved it a few times, but the steps is what's most important. Noticing that the first person doesn't follow the pattern means we can't code them as part of the loop. Does that make sense right there, Kayla? We'll enter in like 2-3 minutes. But noticing they don't follow the pattern means you don't use them in the for loop. The first person's code was done here because they don't follow the algorithmic pattern that's a repeating pattern for the remaining people. Person 2 through person 250,000 follow the algorithmic pattern, and so we can do them inside the for loop, but person 1 is done outside the for loop because they don't follow the pattern. So because they just turn off one switch, so I said, okay, go to switch 1 and turn it off. That's the code right there for person 1. Go to switch 1 and turn off switch 1. The remaining people need to use the sequence function right here to find out which switches they turn off. So all I did was go right here and say, go to these switches. Like this might as well be the positions they go to and just turn those off. And then it just runs it for every single person. So it just says this person goes to these positions, turns them off. So you could also just go store this right here and say positions, if I knew how to spell, and store the positions of the lights that are turned off right here. And then you could just say, go to those positions in the lights. And once again, we would get the same thing as long as I didn't make any errors. Oh, it's still running. It takes a moment. So it does take a moment. And there's the first 100 prime numbers again. But that might make a little more sense to people if I do a line that says, go to these positions, or like, here's my positions, and then go to those lights in those positions and turn them off. Really good question. Very tough one. And we're going to head off right here, but swing back by for later office hours, everybody. Really great questions. Adam, feel free to ask. KP, great seeing you here. Feel free to ask. We'll do more of assignment 2, maybe some 201. You never know. We'll be doing some office hours here in a little bit. Bye for now. 475. See you soon. Bye.